The TCP/IP model, also called the Internet Protocol Suite, provides a framework that sets the standards for transmitting and receiving data across networks. The model is named after two of its primary protocols, the Transmission Control Protocol, TCP, and the Internet Protocol, IP. Historically, the TCP/IP model was defined with 4 layers. However, as understanding and technology evolved, many references and educators adopted a more detailed 5-layer description. The traditional 4-layered model comprises of the network interface layer, internet layer, transport layer, and application layer. The 5-layer model is divided into physical layer, data link layer, network layer, transport layer, and the application layer. Imagine 2 devices, computer A and computer B, interacting. When computer A sends data to computer B, the process begins at the top. The application layer uses protocols like HTTP for web browsers and SMTP for email applications like Outlook. If computer A communicates via the web with computer B, it generates an HTTP request using a web browser, since HTTP is the standard web communication protocol. Next is the transport layer, responsible for ensuring end-to-end communication. This layer leverages protocols like TCP, which guarantees reliable data transfer, and UDP, which is swifter but might be less reliable. The allocation of appropriate port numbers to data from the application layer also happens on this layer. For instance, in a web communication scenario, the TCP header from computer A would have a designated private source port and a target of port 80, the standard port for web communication. Data combined with a TCP or UDP header becomes a segment. Following this is the network layer, which is responsible for routing packets over the Internet. Upon receiving a segment from the transport layer, it adds an IP protocol header containing IP address information. Here, the IP header includes the source IP address as the IP address of computer A and the destination IP address as the IP address of computer B. This enhanced structure is termed as a packet. The data link layer comes next. In this layer, protocols like Ethernet add MAC address information to the packets from the network layer. The Ethernet header comprises both the source and destination MAC addresses. In addition to the header, a trailer is appended, transforming the structure into a frame. In a computer system, this information is represented in the form of binary data. After that, the physical layer transforms the binary data into the right kind of signal, which could be electrical, optical, or radio waves, for sending it across the chosen network pathway. When computer B receives the transmitted data, it begins the process of decapsulation, following a bottom-up approach as defined by the TCP/IP model. The sequence of steps ensures that the received information is appropriately processed. Initially, the physical layer converts the received signal into binary format. Subsequently, the data link layer examines both the Ethernet header and trailer, extracting the MAC addresses of the source and destination devices. Next, at the network layer, the IP information within the IP header is decoded, and the destination address is verified to confirm that the data is intended for computer B. Moving forward, the transport layer reads the port number and determines that the data should be directed to the destination port 80. Finally, the HTTP request is forwarded to the web server that is actively listening on port 80 on computer B. Upon receiving the initial HTTP request from computer A, the web server on computer B prepares to respond. As computer B is the sender this time, the communication process starts from the application layer, where the web server generates an HTTP response. This response is passed down to the transport layer, where a TCP header, with details such as source and destination port numbers, is appended. As it transitions to the network layer, an IP header is added, embedding both computer B's IP address as source IP and computer A's IP address as destination IP. At the data link layer, the data receives an Ethernet header and trailer, carrying the MAC addresses of the source and destination devices. This frame reaches the physical layer, where it's transformed into transmittable signals, whether electrical or otherwise, and dispatched across the network medium towards computer A. On arrival, computer A decapsulates this data, layer by layer, starting from the physical layer. At the end, computer A's browser gets and shows the HTTP response. And that wraps up our deep dive into the TCP/IP model and its intricate dance of data transmission between devices. If you found this information valuable and learned something new, please hit the like button and subscribe to our channel for more content. If you have any questions or topics you'd like us to cover in future videos, drop a comment below. Thanks for tuning in, and we'll see you in the next one. Stay curious and keep learning.